Hi. Not deserved yet, hold your horses. Hi, I'm Anna. I'm a chapter lead of platform engineering at RTL. And if you don't know what RTL Netherlands is, I have a little slide for you. So what we have is, could I get the mic a little bit lower? Sorry? Yeah, thanks. So we have TV channels. We also have online platforms like video streaming to watch series, movies, specifically Dutch content, and RTL News and Bayern Radar for the weather. We are also advertising house for other companies. So these are our customer-facing activities. But we also have a lot of internal tools that we support our redactors, writers, content managers, with different process automations that we have to support internally. And the platform that I work with is supporting all of those products underneath, hidden. We are out there. So first I want to tell you a little bit about what platform engineering is not. So imagine we have a team, any team, they want to build something, let's say it's a house, and they think, okay, we're going to take one that is interested a little bit, give them some tools, let them work a little bit, they can build a house, why not? So they build a house, and the first version looks like a house, it's not so bad, quite okay, good job, version 0.1. But then we notice, yeah, what's that? So there's a door on the first floor, oops. So we find some open source stairs, we stretch them a bit, maybe it doesn't fit so much, but we can enter, okay. Yeah, oh, oops, we forgot about piping. So we slap it on the outside, it doesn't matter. Can be on the outside, extend the roof a little bit. Okay, we can run with that. Version 0.7. And then we are like, we have to extend. Okay, let's extend. It's okay. Still a house. So this is what platform engineering is not. So the idea with platform engineering is that there's a team that knows exactly what they're doing, that builds building blocks for other people. So they build a house for somebody else. And they know exactly what they're doing, and they can build you a house, not a swimming pool, a house. And it could be a 4-story house, it could be a small house with a garage, what you want. They can extend it, they can rebuild it for you if you feel like you don't like it anymore. So that's what platform engineering is for me. It's a team of specialists that know what they're doing, love what they're doing, they didn't learn it yesterday, and they want to basically help you to have a house so that you can do what you want with your house and not focus on building it. So there's many platform engineering definitions, but what we specifically focus on is to foster agility, scalability, and consistency for other engineering teams, and provide the tools and best practices for them so that they can deliver value. Basically, a platform engineering team also hides this complexity that are the, let's say, complex systems underneath, so that the teams that are bringing value can bring value fast. And yeah, so if business people ask me about platform team, and they do often because it's confusing what this team is about, then I point to those 4 values. And that's enhance productivity, so you can be productive on a day, so you don't have to wait, basically. Another one is standardization and consistency, so that is, let's say, all of our apps have this, or all of our apps supply that, or are compliant with that. Another one is scalability and reliability, so we can scale to traffic, we can scale down from traffic. And reliability, of course, is nobody wants their app to be down when we need it. Nobody wants to be called in the morning, in the middle of the night, why is my app not working? So we want to be reliable. And then the most important to business is time to market, so that we can try to think fast, deliver to users what they want, new features, but also fixes and different compliance features. And then what we checked, what our user needs are are similar things. So they need efficiency, they need reliability, security, speed. They want to own things, they want to take care of their own things, and they want to be compliant without working very hard on it. So they want that to be done for them. So what is this team? What is the composition of the team? We have a lot of expertises in the team. So there's not like, say, a study that would bring us platform engineers. We have to combine different expertises. So we have cloud engineers, obviously. We need people to understand the cloud and build for it, specifically with security and networking backgrounds. We have systems engineers to look at the big picture of things. We have site reliability engineers, of course. We have data engineers because we also build data platforms. And we have software engineers to build this platform as a product to actually deliver features to our users that are internal users, developers, and engineers. And these are the people that worked on it. And we also have a mission, and our mission is to be of service to people, to other developers, and to people that actually deliver value for the company. All right, so, nice mistake in my slide, never mind. So we have these 10 principles, and I'll go through all of them slowly and explain to you. So first one is automation everywhere. And the idea is that it's not automation of everything. So we want in all of our stack to have some automation, and automation that is worth making, that we know we will use it again and again, is important for us. We're a small team. We don't have so much time to sit there and do things manually. We want things automated. So we automate our orchestration, so all the lifecycle management. For example, Kubernetes does a lot of things for us that we don't have to do. Governance, we have different tools to tell us about the governance. Are we breaking something? Are we compliant? Same with compliance. Observability, so that we can see all the things that are in our system. So we add this as a default to all of our tools, so we can observe all of our tools and bring the data back to the developers and engineers. And yeah, integration delivery, we have continuous integration, continuous delivery, but not only for developers, also all the features that we ship, they are also with CI/CD pipelines, because we want to also ship fast. Second is, yes, so version control as a source of truth. So for software engineer, this is easy. I'm a software engineer, survivor software engineer, and we put everything in source control system, but with platform engineering, we put more. We also want our infrastructure in source control. We also want configuration, access, all of our alerts, policies. All of this is in code because we don't want to always check how it is in the system. We want to have a single source of truth that we are sure this is how it should be, and if it's not, GitOps, for us, something else, maybe for you, we'll correct it. So we don't have infrastructure drift, configuration drift. We always know what it should be. And of course, the left side of the thing is static, immutable, and the right side is dynamic, right? So you have to, let's say, configure things on the left side and see how it reflects on the right side with some margins of scale or resiliency. We also want to monitor everything. So a lot of data come from the platform. So we have traces, logs, and metrics, but we have different SLIs that we ourselves are using, but also that we offer to the teams. And we also help teams to set up different SLIs, what they want to see. When do you say your app is good? When do you say it's bad? What is exactly the border for you? And that you can have your own dashboards to monitor. And we also monitor things like costs. We monitor what kind of alerts there were on the service over time to show you, okay, this is how your app is behaving. And different anomalies and what is happening exactly for a specific app, but also for the whole platform and for the whole apps as a whole. And that means that it's very easy to create different KPI visualization in different visualization tools. But also it means that we are already tracking your data. You just have to ask us, oh, do you know what is the uptime of my app? Yeah, of course. You can see last 5 months, this was it. Another thing is security by design. So it is, for many people, it's quite hard to put the security in this DevOps cycle on your development, and it usually appears more at the production side. So when your app has to go to production, you also have security checks. But what we do for our teams is we supply them with tools that are very early, that would tell them already in your testing stage, what is wrong, what should you fix, so it doesn't land in production. You have to do that earlier. So we have with tools and best practices and trainings to help the teams. Another thing is what we really want to have is self-service as a platform, and that's self-service of the platform, and that means that we really want our users to do the things without us. So we want to be invisible. We want to be in the background. We want people to have things automatically and as soon as possible. But it can be two ways. Let's say you go to a supermarket. You have a list of your things that you want to buy. And you can get anything nowadays, right? So you buy all your ingredients and you want to make a pizza, okay? So you probably need somebody to know how to make a pizza. It's an art. If you ask Italian people, you have to make it, you have to spend time making it, and then wait a bit, usually, and then you have a pizza, right? This process can be done by can be done manually and by a person that doesn't have to be an expert, by an expert. So you have to know what you're doing to go once. And if it's done by a beginner, and you have to try again. Doesn't look like pizza, doesn't look like pizza. Go back, and do it again. So it takes much longer time if you do it this way. Although you can get all the ingredients in the world and all the recipes online, your first batch is not going to be amazing. But another way of self-service is that you have specific menu to choose from, and you say, I want margarita. And you press a button, and there's somebody that knows exactly what they are doing. They add special sauce to it because they know all the customers like it. They bake it for you, perfect. And it's done exactly as you want it. It's a margarita. And the idea with this is that you have limited choice on your self-service. So it's not a lot of things that you can have. That's why for us, but here it's very fast. So you order margarita, you have it in a few minutes, as long as it takes to bake it. So it's very fast and it's automated. People that are doing it, they know what they're doing exactly. So the only problem with this is that you have a limited menu. But if you update this menu to the needs of the self-service that you provide, you can have these products easily available for people very fast to deliver service without a lot of effort. Next one is resilient and scalability. So we want the platform to be observant. We want to observe everything. We want the platform to be robust. And it's a principle, so therefore it's a dream, right? And to have automatic failover and recovery from different kind of failures. We want to grow, but we also want to shrink. We want to sometimes be big, sometimes be small. Now we need to cut costs, or we don't have a lot of traffic. We don't want to have a big footprint. Now it's a big event, so we want to scale up to what we need. We also want to be adaptive. We know with innovation, there's a lot of tools coming in, a lot of requests all the time. Now with AI, every day there's something new, and we ask for something new. So we want to be ready for that. So we designed the system to be, let's say, resilient to all of this change. So we can replace one thing, add another thing, easily deliver it to the users fast. And we want to be prepared. So if something big happens, so when we're on call, if something happens, it's big. It's not small things. So we also want to be prepared for when something big happens. So we are also not... that we can also manage it in the middle of the night when it happens. Number 7, that's very important for our users. So we really want to help them to deliver features fast. And that means that they can deliver smaller batches that are less risk, and that they can really accelerate their innovation and their process. So we offer them rapid feedback. So that means that the app can go fast to production, or at least to acceptance, to do a majority of tests. We want to mitigate the risks that they have. So we have, for example, automatic rollback. When your app doesn't meet SLAs, it's going to be rolled back and try again next time. CI/CD pipelines that will take away all the processes for you to release to production. And yeah, of course, reliability and scalability underneath to scale to your needs. And then, yeah, of course, continuous improvement that we want to offer to our customers. And last one, also, I think in the previous presentation, it was there. So we really encourage developers to own what they build. And that means if their app breaks, they are on the call in the middle of the night, and we are sleeping soundly in our bed because nothing is happening with the platform. And that means also not only code, but also their cost, their APIs, their data, everything that the team is scoped for, that's their responsibility. And if something happens, we also take care of our responsibility. And we also want our team to make data-driven decisions. So we supply a lot of data to the teams, but every team is very different. They have different expectations of what is good and what is bad with their development. So we also offer them trainings of how to actually design your SLIs or KPIs, whatever you call them, and actually try to track them and look at them periodically and talk about them in a team, how to improve your application. There are some things that you might not notice from your users that is very clear if you start looking at the data. And last one, which should not be the last one, but it is here, is that we really are very, very interested in what our developers and engineers are telling us. So we are an internal product that is for a small group of people that are bringing value to the company. So our users are a small group and very, very important. So what they need, what they really, really need, we have to provide. So we create a trust and collaboration environment with them so they can tell us if they like something or if they love something. We encourage feedback from them, so again, they can tell us. We promote accountability, so they own their stuff, we also own our stuff, and we collaborate on making both better. And we facilitate different knowledge sharing, because what we do is complex, what they do is complex. We have to know something about each other's world. So we teach them a little bit about our world, and they teach us a little bit about their world, and then we can collaborate only then. So these were the 10 principles. And now how we use them. So first of all, we work in a very distributed way. So engineers in my team, they work by themselves on features. And it's good to have these principles to understand where you are going. So how does this new feature fit in our principle? Does it fit? Yes, we go for it. If it doesn't fit, maybe you have to question our principles, or we have to change the feature. And people can make decisions by themselves based on the principles. We see that with the agents that we write to help us with different parts of our work, we can see that they do very well with very generic description of what we want to build. So we also use principles to steer our agents to do the work as we want to do, and not what the internet says we want to do, like Tiago was saying earlier. So that we also provide this best practices in written form, these principles in written form, so that we can get help from AI that we exactly need, and not the generic help. Yeah, and what we are working on this year is, so all of this is not finished. So these are principles, these are somewhere out there. We want to reach there, but it seems like we always work on security, but it is important. So we also care about that. So we try to make our security better. We work on culture. We work a lot on accountability, especially with legacy part of our infrastructure. Who owns it? Who should fix it? Who should update it? Who should create it? And we also look more even on our self-service. So there's a lot of automation. Things are easier, but they can be easier. They can be faster. They can be better in some areas that developers and engineers really need it, especially in this time of increased innovation when we are trying new tools, want to deliver things faster. And then it's really important to have a good self-service. Yeah, that's me.